Hey, so here's a little bit about my background. My name is Matthew Smith, and I started my career in the early 1990s at South Africa's national electricity utility, ESKOM. And for some reason, when I did my very first practical work experience assignment, my mentor and supervisor asked me, "Hey, do you know anything about computers?" And I sort of said, "Well, yeah, I have been playing with computers since I was a kid, programming home computers. I took computer studies at high school. That's a whole other story. I didn't really like programming, but I really enjoyed computing. And because of that, I was given this assignment to take a Fortran program that had been running for years on a ancient CDC cyber mainframe and port this Fortran program to run on a mini computer workstation. And this back in 1990 was my very first exposure to, number one, mainframe computing, and number two, Unix workstations. And actually, it was my very first 30 computer workstation that I'd ever seen in my life. And to move the actual source code of the Fortran code from the mainframe to the mini computer workstation, we actually had to ship it via a PC. It was really crazy because there was a way of interfacing to the CDC Cyber through a gateway that was actually running on an Amdahl machine, a mainframe, and actually the main mainframe system for the company, which was running all the ERP and productivity tools. And it was possible to transfer files from the CDC Cyber to the Amdahl, and then using basically a TN3270, which is an IBM terminal emulator, which was running in DOS on a 286 PC, we were able to download a file and store it onto a local hard drive. But this is back in the days when hard drives were like 20 or 40 megabytes and computers only had 1 megabyte of RAM. And well, the way we ended up transferring the program from that local PC, which was literally an office PC, was to use a software application called TeamTalk and do a serial data transfer. So basically hooking up an R232 port on the mini computer workstation, which was, by the way, an Apollo workstation running Aegis and the domain window system. The Apollo was actually purchased by Hewlett Packard somewhere in the early 1990s, and the Apollo product line was merged into Hewlett Packard's series of Unix systems, the HP 9000 series. So HP 9700 workstations are actually what resulted from the acquisition of Apollo computer. Again, that's a different story for another time. On the back of that, so here I am, I'm 18 years old. I had programmed in Pascal in BASIC, and I dabbled a bit with doing Z80 machine code, Z80 assembly on a Sinclair ZX Spectrum. But I had never seen Fortran in my life, and I was unfamiliar with this environment. And so that really threw me in the deep end, and having to figure out, using some system manuals and programming manuals, on what are the differences between Fortran 55, which is what ran on the CDC Cyber mainframe, and Fortran 77, which was the Fortran environment on the Apollo mini computer workstation. That took a bit of getting used to. And so for 6 weeks during my long summer vacation, that's what I did every day, was like figuring out how are we going to actually get this voltage drop calculator software. This was basically a small utility that was used by the network planning department to calculate voltage drop in the network. Anyway, mission accomplished. And that kind of got me interested in not just computing, but also how computers are networked. How does connectivity play a role in bringing together different types of systems? And of course, seeing that work in a heterogeneous environment where we're using different communication protocols to make everything work. Well, I got the opportunity a couple of years later to build an interesting little data extraction tool for for the network planning department. I actually wasn't working in the network planning department. I was assigned into the metering and telecontrol group, which was looking after SCADA systems and electricity metering for the regional distribution network. And I'd obviously stayed in touch with some of the engineers I knew from network planning. And it just so happened that one of them had this interesting issue where they were looking at feeding their network simulation software called PSSE, Power System Simulator for Engineers, which was actually the main software package that ran on these Apollo workstations, basically looking at bringing in real analog data, so historical current and voltage data from the telecontrol system. So basically this big SCADA that was running for coordinating network operations and dispatch. The telecontrol system was running on a PDP-1134, an AB hot swap, hot standby system that had been commissioned in the 70s. To be honest, this is the oldest computer system that I have ever worked on. And we're going back now to 1994, where I was still in training. I hadn't actually graduated and started full-time employment. I was still in training, but I was shadowing the technicians who were responsible for maintaining this SCADA system, what was known as the master station. And this master station was meant to be decommissioned, and it was being very carefully maintained because it was so old and obsolete, but yet serving a vital function. Anyway, so the brief was pretty simple. It was like, well, can you connect a data logging PC to a printer port on the PDP-1134? So basically an RS-232 serial printer port that was normally connected to a line printer that would then print out lines of these analog values that were being seen in the SCADA system. And basically they were being printed out at various intervals, and effectively you ended up with several pages of printout. Well, what the network planning team used to do before that is they would actually take the printout, give it to a secretary, and ask the secretary to type it in by hand into the right format that could be loaded into PSSE. And this was very laborious and obviously annoyed a lot of folks. So the challenge was how to write a transform that would take data that was in one format and turn it into a different format. So basically taking an input file that was like serial data that was being saved onto a PC, running a converter program. And I wrote this converter program in Turbo Pascal. For some reason, I had basically stuck with Turbo Pascal as a programming tool, and wrote this little program in Turbo Pascal that would effectively read values that were delimited in a certain way, and then basically massage them and output the correct file format that PSSE was expecting. So that worked pretty well. And that got me also thinking about, well, all right, so for sure, there's probably some scope to be able to do this in a better way. Well, towards the end of my studies, I had the opportunity of joining the project team to basically build a whole new SCADA that was replacing the old PDP-1134 based system, which was originally supplied by Westinghouse. It was known as a Westac 6 master station. And we replaced Westac 6 with a new system that was also made by Westinghouse. In fact, this division of Westinghouse was actually acquired by Schneider Electric in 1996. And mid-project, we're in the process of actually finishing factory acceptance testing and moving on to site acceptance testing when Schneider buys Westinghouse Systems Limited. And we suddenly have some Schneider people turn up to take a look at what's happening with the project, which was really fascinating. Very first time I met someone from France professionally, and here I am. I've been living and based in France for 25 years, since the year 2000. And I actually met that gentleman about 10 years ago at a trade show where my company Field Cloud was exhibiting some of our IoT solutions. And this guy came up to the stand and we got chatting in French. And I suddenly looked at him and was like, saw his name badge, said, "Hey, you look familiar. Did you ever come to South Africa in the 90s with Schneider Electric?" And he said, "Yeah, I did." And I said, "Well, we know each other." It was really quite amazing. But yeah, I kind of digress on this, and it's a bit of a long-winded story, but those formative years at ESKOM were extremely compelling and very solid foundation. Once the project had been fully implemented, I kind of thought about what my next steps would be. My former employer, ESKOM, had pretty much said that, well, we're done with this project and we now need to maintain it and we need to operate it. You guys from the project team are now going to become the maintenance and operations team for looking after this master station. And I guess in my youthful arrogance, I mean, hell, I was like 25 years old back then, and it kind of didn't sit right. I wanted to kind of be involved in new stuff, do new projects, create things. And I thought that maintenance was boring, and maintenance was really for people that were kind of set in their ways and didn't really see a future. And that was wrong. How little did I realize it took me many years in my next steps of my career to realize that maintenance and long-term sustainability of systems is actually vitally important. And if you are not having continuity between project and implementation and then operations and maintenance, you are really going to end up with some serious issues with loss of institutional memory. So, of course, in 1997, being young and kind of eager to, do the next thing in my career, I left, I quit, and I got recruited by a very large international company, well-known oil field service company. Look up my LinkedIn profile, you'll know exactly who I'm talking about. And I spent the next 13 years working in a variety of roles. I spent 3 years working in Nigeria, looking after very old mid-range computing systems that were used for doing data processing, or field data, oil well data acquisition, data processing. And the reason why I got sent to Nigeria is because there was this ancient old computing center, literally a walk-in, mini data center that was running some 1980s vintage VAX computers. And I'd been working with VAX and the VMS and Open VMS operating systems for the telecontrol project for ESKOM. And it just seemed to make sense that I would actually, have some, expertise that would be of use to my new employer in a country like Nigeria. And that's why they sent me there, was because there was this whole bunch of like really old and very obsolete VAX systems that were still being used for data processing. And yeah, to be honest, it was kind of funny because I kind of had to sort of go back into the past again. And it was less about doing new projects, although there were some that were quite interesting. I decided to focus on some really chronic network connectivity issues. Telecommunications in Nigeria was a complete disaster nightmare in the late 1990s. And that's where I got into satellite communications and figured out a way of reorganizing space segments. So in other words, the satellite bandwidth that was being leased for something known as SCPC, or single carrier per channel, so that we could provide better bandwidth in the right places and actually have international bandwidth from where the majority of field operations was occurring, which was in Port Harcourt, Nigeria. And that was pretty that was pretty wild. That was pretty wild because when I got into that role, I started as an IT engineer, and by late 1998, I ended up moving into taking over responsibility, and I became the IT manager. I'm not even 27 years old, and I become the IT manager for all of the company's oilfield services business units that are operating in Nigeria, which at that time was about a $300 million business in terms of annual revenue. 1999 came around, and there was a major downturn. This was an aftershock of the Asian financial crisis in late 1998. The price of oil plummeted to $9 a barrel, and as any company does, you end up having to make some hard decisions about workforce reduction. And, the operation in Nigeria went from 2,500 people to 650 full-time employees, which is pretty brutal. And all the while working on fixing bad connectivity, atrocious quality network infrastructure, and building a new finance center for back office finance. So all of the accounts receivables, payable, etc., all of those back office support functions, that was one thing that was being rationalized, and building a new center that required better connectivity. So it was kind of interesting without having any kind of like real budget commitment, being able to get a few $1 million of capex allocated. And again, I was IT manager, but as an IT manager, to coordinate and to obviously deal with operations managers who had P&L responsibility. And this was the early days of looking at a shared service model, having to figure out, so, all right, who is able to justify allocating capex in this way for IT infrastructure, and trying to mutualize. And I think what worked is that I was able to build a very clear and simple business case, which was based on how much money was being wasted on international telephone calls through the local PTT, the national PTT NITEL. And as part of the network upgrade and the allocation of, again, satellite bandwidth, as well as new higher capacity wide area networking using private point-to-point radio links, we were able to add voice over frame relay. And by refreshing the private automatic branch exchanges, the PABXs for telecom, to be able to switch a big chunk of phone calls away from using the PSTN, the public operated telecom network, across onto private inter-office calling. So there was obviously calling between offices, but we were also able to bring voice over frame relay over satellite to a landing point, and having interconnects in London that were allowed staff to talk to, for example, HQ in Paris or other product centers around the world without having to pay long distance charges. Alone, that back of the envelope calculation pretty much gave a 6-month return on investment. And well, the operation managers that I was engaging with loved that, and realized that they would also get a major network infrastructure boost at the same time, with the better quality of local area network and more stability with sending, receiving emails, and obviously using other applications that are on the network. It was a grueling exercise, and hell, I felt pretty burnt out at the end of 1999, not to mention all of the panic around the year 2000 bug, which turned out to be a non-issue that came and went. And then somewhere around early 2000, I really had a long, hard think of my future. I took over some temporary project management of a really interesting project that was being done for the United Nations Development Program, UNDP, which was to build Namibia's very first dial-up internet service provider infrastructure. And one of the divisions in the company I used to work with, which actually had been a joint venture with a telecom operator, the joint venture was called Omnes. I had an interesting product that they used to sell, which is called Spin. service provider internet node. And SPIN was actually used by the UNDP to bring internet connectivity to emerging markets and small nations. And Namibia was one of the beneficiaries of a UNDP funded program to build up their very first ISP. So I had a hand in building Namibia's very first dial-up ISP, and filled in for the project manager who had taken a long vacation, or a long, well-deserved vacation. So I filled in for that. And then, exactly 25 years ago, in the year 2000, end of April 2000, I got on a plane and I flew to Paris, and ended up choosing between relocating to France and having an assignment in Paris, or relocating to Austin, Texas, to have an assignment in the USA. I chose France. I chose France for two reasons. One is it's more or less the same time zone as South Africa, so it was a lot easier to travel just north and south to get back home and see the family. And then the second, and probably the most important reason, was to actually learn French and to be exposed to French culture. I'd worked with French people and French-speaking people in Nigeria, and I was starting to become quite fascinated, and I saw how much of an important language it actually is when it comes to business, particularly in West Africa. So that's pretty much kind of like where I ended up 25 years ago, was working in corporate IT in the headquarters location in Paris, and being part of a team that was called Global Infrastructure. And Global Infrastructure was all about looking after the entire worldwide data communications network and telecom infrastructure, and core services that were part of that infrastructure. So everything to do with DNS, actual router management, fleet of about 1,500 Cisco routers, firewalls, directory services, messaging through email. And then later on, and this was at the start of a sort of a big consolidation drive to kind of make IT infrastructure a little bit more coherent around the world, was to add in IP address management, DHCP configuration, Windows 2000 Active Directory services as well, to create a set of domains that actually spanned multiple geographic regions. Fascinating time, and I ended up taking on the responsibility of driving DNS, domain name system consolidation, which was to take almost 500 primary DNS servers that were spread around the globe in about 100 countries, and to consolidate all onto a single primary name server, with then some key secondary name servers that were geographically distributed. And not only did we have to engage hundreds of system administrators that were obviously responsible for looking after these different DNS and primary name servers, some of them were very reluctant to give up control and local control. And there was a lot of arguments about the merits of actually doing a consolidation drive, which I think was fascinating, because that got me into the whole thing of, well, how do you actually align and coordinate across different business units, different geographical markets, languages, cultures, practices, etc., in order to, again, meet a corporate objective, which is to consolidate and standardize. And then, again, what tools do you provide, and how do you, again, transform a way of working? So again, managing change was really important there. Was it perfect? Definitely not. But, we got there in the end, and sort of come, mid-late 2001, the project had been executed, the milestone had been reached, and, well, the company was running a single primary DNS server with a tool that provided delegated DNS administration. And was also interesting there was that there was originally a plan to spend a lot of money on some licensing on a commercial solution, but that commercial solution did not provide the fine-grained distributed access, or the way you could decentralize access and delegate different levels of access across, again, a few hundred different DNS administrators. So we ended up going for an open source tool, which is called Webman, which I believe is still around, but we just simply implemented the DNS module in Webman and tidied it up, did a little bit of hardening around it, and then linked that with user account creation that was keyed off our corporate LDAP directory. Yeah, so when that DNS consolidation project had come to an end and I pretty much had taken over host master duties and had this responsibility of governing DNS, we then tackled, or I was asked to tackle, IP address management and IP allocations. There was actually quite an interesting set of issues there, which had to do with public IP address block assignments. My former employer had been a very early user of the global public internet and had received IP space back in the mid 1980s. It had also obtained additional IP address blocks through the acquisition of different companies, and there had also been some divestitures where companies had been disposed of or had got new owners who had either left behind IP space that was still registered to my former employer or were kind of in some kind of legal limbo because the contact details were still to the old legal entity. So anyway, I was tasked to work with the IT legal counsel on cleaning all of this up. So I ended up engaging with the American Registry for Internet Numbers, ARIN, and started going through a long process of cleaning up the IP block allocations, and were able to reclaim through a bit of legal pressure that my colleague, IT legal counsel, was able to exert on some folks that thought it was appropriate to try and sneakily claim IP space that actually was officially allocated to the company. And we also had to deal with some cyber squatting cases of domain names that were improperly registered or had been registered by the company, but the actual control of the domain registration was in the hands of other people. And that was really great fun as well. I guess the other thing that was also quite curious back in the early 2000s was dealing with, well, what are known as dual use technologies. Back in those days, encryption wasn't something that we all took for granted. There were restrictions on encryption technology and where it could be used and what the strength of the encryption was. And in the very early days of using VPNs, IPsec VPNs, it became important that the company was compliant in different jurisdictions. So I ended up having to build up some expertise and familiarize myself with the Wassenaar Treaty, which governs and regulates dual use technology. So dual use basically means that it's technology that can be used for both military and civilian applications. A lot of encryption technology falls under that particular classification. Again, working with IT legal counsel, having to, again, do some rather sensitive things with, again, jurisdictions that, again, were not necessarily, how can I say, well, for compliance reasons, had to be dealt with in a special way due to regulations, in-country regulations. So I became a really fascinated, but also very engaged in dealing with regulatory concerns and regulatory compliance. And that definitely stuck with me later on in my career, where I ended up having to deal with international telecom regulations and market access issues for another project that I worked on. But I'm kind of getting ahead of the story. So coming back to encryption. So two things, right? So obviously securing network traffic. So in other words, using VPN, two types of VPN, site-to-site VPN. So being able to use a public network, so like an internet connection, and then tunneling a private wide area network traffic between two different company sites. in some markets, it was impossible to purchase leased bandwidth. So you can just go and order a leased line or a frame relay circuit or an ATM circuit from a telco. But you could go to an ISP and have the ISP come deliver a customer premise equipment router and give you access to their public internet connection. And it became a way of being able to connect sites that previously could never be connected because there were no leased line services in the market in that particular country. And so that was a lot of fun, being part of some of the very first site-to-site VPN IPsec deployments. Then the other use case was for so-called road warrior connectivity, where you would have people traveling very often internationally who would be carrying a laptop with them, and instead of dialing up to a company network directly, I mean, this is the days where, we used to run multiple modem banks and used to have our own dial-up access to access the corporate network. As broadband was being deployed in the early 2000s, it was a lot more interesting to connect to, for example, Ethernet or very early Wi-Fi deployments. In fact, I remember traveling in the United States in the early 2000s, and you didn't have Wi-Fi in the hotel, but you did have an RJ45 port, a physical wired Ethernet connection. And I remember, taking my laptop, taking a PCA CIA card with a RJ jack and connecting a patch cable to the hotel room's internet access via Ethernet. And that was pretty cool. And so the ability to have some kind of road warrior VPN for people who travel was pretty important. And that sort of paid dividends later on, where, we started switching from dial-up access using modems, 56K modems, to having always on 24/7 broadband using ADSL or cable modem. That was a way where you could then, by using a client software, and we use Checkpoint VPN software for the client. Our IT security team was pretty interesting because they were very keen on ensuring that we had strong authentication. And because my former employer was also the world's largest manufacturer of smart card technologies and had actually invented the Java card format that was then licensed back to Sun Microsystems as part of the Java environment. There was a lot of groundbreaking work that was being done using smart card technology, and it made sense to use smart cards as a token for public key cryptography. And so in addition to using Checkpoint VPN, we also used to use Entrust PKI. It had a certificate of authority, and basically a whole system for being able to, again, by using a private key that is on a smart card, have a public key that's generated that is then linked back into this certificate authority. And that was a pretty incredible piece of infrastructure that had been put together by some incredibly insightful and maverick engineers in the company. And so I ended up taking responsibility for coordinating all of this. And around 2002, 2003, ended up driving a program to do a bulk corporate badge. So basically a corporate smart card deployment. So we ended up deploying 40,000 corporate badges across the company to people who had never received a smart card before. And this was an interesting badge format because we obviously had an ISO format, chip card, which was actually using a technology that had been invented by my former employer called eGate, which actually included USB as well as the ISO format pin layout on the actual smart card chip. But that was also coupled with a MyFair contactless chip. You're probably familiar today with NFC, near field communication, but before we had NFC as a standard, we used to use MyFair, which was a standard that was invented by Philips Electronics. Yeah, MyFair was used for opening doors, so basically using your corporate badge to get in and out of company buildings. And there was a lot of emphasis placed on standardizing door access control systems to make sure that all door access controls were using MyFair readers. And even though the door access control systems were distributed. There was no central coordination or central management of the actual door access system. So each site pretty much had autonomy on that. It was just incredibly easy to use the same corporate badge. So unlike some large enterprises that I've worked with as customers more recently who do not have a single corporate badge standard. You have employees from one division, one location, one geographic location, travel to another location, and they can't use their corporate badge to get into the other building. They have to get a visitor badge allocated to them, which just ties up reception and creates a lot of admin hassle when it comes to organizing access by legitimate employees. And of course, the other nice thing was that if you were a worker, an employee that needed access to more than one site, you could actually have your badge activated permanently. That was pretty interesting. What glued all of this together was having a single corporate directory. And again, this was something that was also chosen to be best of breed. This is well before Microsoft had brought out a Windows Active Directory environment. And so the idea was to use LDAP, Lightweight Directory Access Protocol, as the core for corporate directory. And it was actually a homegrown system to provide the corporate directory access through a web interface. Behind the scenes was a system that was originally using the old, later on it became known as Sun One directory server. My memory is escaping me as to the old iPlanet. That was the name of the alliance that was done between Sun Microsystems and Netscape Communications Corporation. So Netscape, the guys who did that very well-known web browser, had also gotten into building application software stacks, platform software for running web applications, and had formed an alliance with Sun, which is called iPlanet. And so the iPlanet directory server was the directory server that was originally used. And then that obviously became Sun One. And for the longest time, the corporate directory was running on this Sun One directory server for the LDAP backend, but then the actual web interface was as homegrown, completely written in Perl, by the way, which is this scripting language that no one really talks about these days. It's been eclipsed by Python and other more modern scripting environments. But yeah, it was written in Perl. It did the job really well. And we had all sorts of interesting integrations. A lot of them were written in Perl. And I used to write a lot of Perl scripts as well to do data extraction, bulk data manipulations in the LDAP directory. We used it to generate basically batch files for doing smart card production. So we would effectively generate a list of users that were going to receive, or employees that were going to receive, corporate badges, and we'd effectively grab their details, massage things, and download photos that were stored in the LDAP backend and use that. And so this also gave a great set of direction to basically geographically dispersed business units where local management were empowered to, again, entice employees to clean up their corporate directory record, their LDAP record, make sure that they had the right type of photo. We had a big campaign to ensure that good passport type photos were taken properly. So you couldn't put a picture of your cat or a cartoon, which is what, was originally used for. It was kind of more of a social thing to have this directory. If I go back before LDAP, in fact, when I first joined the company, it was actually using a system called PH. PH was this really interesting old precursor that was simply a way of having a sort of a phone book online where you could know like where someone is, who they are, what their phone number is, and what their email address is. And I mean, that's kind of was the basis for using LDAP. Really interesting. So when that whole PKI smart card rollout was done and dusted, I got into enterprise architecture, and in particular looking at the actual infrastructure architecture. And there was an initiative that was spearheaded by a couple of former colleagues of mine who were driving enterprise architecture, and were very big on using things like the Zachman framework. Something I definitely still use today and work with clients is Zachman framework allows you to really build a very clear linkage between high order, high level business processes and all the way down to underlying component level infrastructure. It's a great way for framing things and presenting things visually. But yeah, my focus was on infrastructure, and that was at a time when there was quite a major push towards outsourcing and outsourcing data centers. So I got involved in some data center builds or migrations, how data centers would be closed down and relocated into third-party hosting, what the implications were, how would the outsource vendor actually access underlying infrastructure in a way that doesn't impede on application traffic. And that was a fascinating process. Yeah, and I think towards the end of that stint, so I spent 7 years working in corporate IT from 2000 until beginning of 2007. And towards the tail end of that whole long assignment, I was looking at, we had implemented a whole homegrown IP address management tool, which allowed us to track subnet allocations across the entire globe on the global network. There was also a router audit tool that had been deployed, and that was really useful for auditing Cisco router configurations. And then another big thing was also looking at master data. So whereas LDAP, the corporate directory, was for master data for people, there was master data for human resources information, so things that were linked to payroll and employees. So employee numbers were master dated in SAP. And obviously, there were routines that allowed master data to then be synchronized with the directory server. And then when it came to geographic locations, actual physical buildings and sites, campuses, we put together that was actually the very first Web 2.0 intranet application that was built, which actually used the Google Maps API to provide a map-based view of all the geographic sites. And so we were pushing to create site identifiers, having site records. Those site records were then basically synchronized with LDAP. So LDAP was slaved off this master site database and allow people to then more clearly sort of be assigned to a site, a physical location. And this was kind of important for IT cost allocation. So in other words, dealing with like who pays a fair share for IT infrastructure, but it was also used for physical access control, because now we're able to, again, know very clearly and unambiguously who actually works at a particular site. So yeah, that was all pretty cool. Around beginning of 2007, I had a quite radical shift in my career, and I moved out of corporate IT, and I ended up working in product development, looking at remote connectivity and remote applications. That was part of a huge program to build what was called global real-time infrastructure, effectively a data exchange platform with what today we would call industrial IoT, but basically having OT equipment, data acquisition systems, SCADA that would be located at customer well sites, connecting that using gateways or using embedded devices that would extract data from instruments or equipment, and then convey this data across communication networks into this big data exchange platform. Fascinating stuff. So that's where I kind of really reconnected a lot with satellite communications. My big project was actually doing a global rollout of Inmarsat broadband global area network, or BGAN, which is a mobile satellite technology that Inmarsat introduced around the end of 2006 commercially. And so we caught the very beginning of that whole wave of having very small broadband satellite terminals, size of a shoebox, basically, that could be taken into the field and used either by people or by physical installations, unmanned installations, to provide broadband IP connectivity between very remote places and these more centralized data exchange platforms. Yeah, and there was a lot of figuring out, a lot of qualification, and certainly a lot of alignment and coordination that was required. I think I may have definitely stumbled in building up a strong consensus and a strong alignment between different product engineering teams that were working on data acquisition and instrumentation. And well, I also think about some of the politics that were involved in the organization at that time. 2008 came around and we had the big global financial crisis. Yeah, literally within a year after that, I was out of the company and founding my own business, which is called Field Cloud. And I've been running Field Cloud for 15 years now, since the end of 2009. And, Field Cloud is a specialist consulting and systems integration business. We work specifically to help advise and transform manufacturers, industries to overcome their challenges of breaking down organizational silos, digitizing their instruments, their infrastructure, modernizing things, grappling with obsolescence, legacy systems, how to turn something which is seen as a bad legacy into a good legacy for future generations. And that way, I've become the guardian of institutional knowledge.